Hello kids, welcome to Victory Pure English JEE batch for all of you people. One short lecture we're gonna do on basic graphs and graph transformations. As you guys know that the relevant of graphs in JEE questions is very huge. By using these graphs, you will be able to understand problems in a different way and you can solve the problems in a relatively shorter time. So it's very important to understand these topics. That's why here we are going into the session to nail this particular topic, kids. So first we're gonna have a look at some basic graphs. I hope you guys are aware that in the chapter parabola, you might have learnt that y square is equal to 4ax is a parabola opening rightwards. Yes or no? Where a was positive. I hope you have studied this topic where a is obviously greater than 0. Now if you want to draw the graph of y is equal to under root of x. Now we know that whatever is written inside the under root has to be greater than or equal to 0 only, number 1. And whatever this value will be coming will be a positive value only, because you know root 4 is nothing but equal to 2, not plus minus 2. So when we have a look at this graph, y can never take negative values. So basically we remove this particular portion so that we get the graph of y equal to root x. We should be absolutely clear with this. Number 2, if you want to draw these two graphs, y equal to root x and y equal to x. Y equal to x, I hope you are aware, is a straight line passing from origin having a slope. How much? -1, isn't it? And you know obviously how to draw y equal to root x wala graph. Yes kids, easy graphs. Alright, so moving ahead, let's see how these two graphs look like on a single graph paper. Obviously we can see that these two equations meet at a point. What points? If we square this, we can write it down like this. If we square both sides, if we are solving for the point of intersection of these two graphs, then obviously we're going to equate the values of y. So root x has to be equal to x, that is, if we square both sides, we get something like this. And now if we take this x square onto the left hand side and taking x common, we get something like this. Now if product of two things is equal to 0, then the first thing is 0 or the second thing is 0, means x is either equal to 0 or x is equal to 1. Yes or no? So there are two solutions. Look, one is this point x equal to 0, another one is this x equal to 1. If we put x equal to 0 in this, we get accordingly y equal to 0. So this is one point of intersection 0, 0, and if we put x equal to 1 in any of these equations, we get the value of y also as 1. That means this is another point of intersection 1, 1. So this is how the two graphs will be looking like. Now, I hope you guys are aware that y equal to x square is a happy smiley shaped graph. Yes or no? Because whenever y is equal to quadratic in x is written, you might have learnt in the chapter quadratic equations that if coefficient of x square is positive, the graph open upwards, and if the coefficient of x square is negative, the graph of a quadratic expression open downwards. Yes or no? So basically whenever quadratic in x is given to us and we need to draw the graph of that particular expression, the graph will be either opening upwards or opening downwards. Now if we have a look at y equal to x square wala graph, it's a y is equal to quadratic in x and coefficient of x square, that is a, is positive in this particular expression, so the graph has to open upwards. So in a single graph paper, if we see these particular three graphs, the three graphs will be looking like this. Yes or no? This blue graph is of y equal to x square. This green graph is of y equal to root x. And this somewhat orange graph is of y is equal to x. So on a single graph paper, they will be looking like this. I hope you people are already aware of all this. Moving ahead, if you want to draw the graph of y equal to x cube, then what we have to do is we have to take the right hand up and left hand down like this. Okay. There is a famous song in Hindi, Bal Butaro Thalle Rakho, something like that, right? So if we have a look at all these graphs in a single graph paper, the graph of y equal to x cube will be looking like this, yellow shaped. Basically this is how the graph of y equal to x cube looks like. Yes, so this yellow one is nothing but y equal to x cube. We can definitely see over here, if we put positive values of x, the positive value of y do we get? And if you put a negative value of x in this, y equal to x cube, we also get a negative value of y only. So the graph of y equal to x cube forms in the quadrant 1 and quadrant 3 only. I hope you can, understand these kind of simple things. Okay. Now if you want to draw the graph of y equal to mx plus c, we know that this is a graph of straight line, yes? So all linear function, linear means what? When the highest power of x and the highest power of y present in the expression is 1, then we do call such expressions as linear functions. And here you guys can see that this graph is nothing but always a straight line. And I hope you can draw the graph of any straight line. As you guys can see over here, that if you want to draw the graph of this particular thing, it is of the form y equal to mx plus c. So it has to be a straight line. And now if you put x equal to, let's say, 0 in this, x equal to 0, if you put over here, you get the value of y. And if you put y ka value equal to 0, you get x equal to what? You get x equal to 15 over 2. So if you mark these 2 points, kids, this is 15 by 2 comma 0, because we have put y equal to 0 over here. So we can see that this is 0 comma 3, plotting these 2 points, and then joining these 2 points is what we do get, nothing but the graph of this straight line. If we have any 2 points on the graph and we are drawing the graph of y equal to mx plus c, we just need to connect those 2 points and we get the graph of that linear function, that is that particular straight line. I hope you guys are already aware of this. Y equal to mod x modulus function, it's a victory shaped V-shaped graph, because I hope you are aware that mod x can be written as plus x if x is greater than equal to 0, because x is the variable, so we are not sure whether x is positive or negative. So whenever x is positive, we can write down mod x as plus x, and whenever x is negative, we will write mod x equal to minus x only. So here in this portion, you guys can see that x is negative, and whenever x is negative, we have to put mod x as minus x. So that's how we get the graph of y equal to minus x line. And whenever x is greater than or equal to 0, we can say that mod of x is equal to plus x only. That's why for the positive values of x, we do have a graph y equal to x for the following function. This is one way of looking at the graphs. Or another way is we can simply put different values of x. We will get accordingly values of y, and plotting these points on a graph, we get nothing but the desired graph, right? Yes or no? 0 comma 0 over here, 1 comma 1 will be there, over here 2 comma 2 will be there, over here minus 1 comma 1 will be there, over here minus 2 comma 2 will be there. Joining all these points, we do get the graph of y equal to mod x. It's a victory shaped graph, and the V is forming at origin. Yes, I hope you guys are aware of all this. Now, in this today's session, our agenda will be to learn how to draw y equal to mod of x minus 2, and not just this, but also different graphical transformations. So this entire session is going to help you a lot with the graphs. So I hope a few people can already draw the graph of this particular thing. So it's not difficult at all. I just told you one thing, and what was that? If we want to draw the graph of y equal to mod x, we form the V-shaped graph at origin. Yes or no? Like this. Why we form this V-shaped figure at origin is because if we equate this thing equal to 0, if we equate this thing inside the modulus to 0, we get nothing but x equal to 1 only, x equal to 0 only. So that's why that this V-shaped graph is forming here at origin. Now if we equate this particular thing written inside the modulus and equate it with 0, we get nothing but equal to x equal to 2. So this time at x equal to 2, we are going to form that V-shaped graph. So that's how the graph of y equal to x minus mod of x minus 2 looks like. As of now, you guys can feel it like this. In this today's lecture, we're gonna learn so many things that after learning those things, you will be able to draw these graphs in a quite easier way. If we wanted to draw, let's say we wanted to draw the graph of y equal to mod of x plus 3, then nothing, equate this x plus 3 with 0, we get x equal to minus 3. So this time this V-shaped graph will be forming at minus 3 comma 0, nothing else. As of now, you guys can feel it like this. equating the thing written inside the modulus equal to 0. So x plus 3 equal to 0, if you do, you get nothing but x equal to minus 3. That's why this V-shaped is going to form at x equal to minus 3. Okay, and that too on the x-axis always. I hope you guys are clear as of now. Okay, y equal to f of x equal to x square. Let's say you want to draw this graph. As we have seen, the graph looks like this. One way is putting different values of x, getting different values of y, plotting all of them together, we get nothing but the graph of y equal to x square, right? Yes. So that's how the graph is going to be formed. One way is saying like this, and I hope you guys are already aware that the graph will be definitely formed like this only. Joining all these points, we do get the shape of y equal to x square wala graph. Now if you want to plot y equal to x square, y equal to x to the power 4, y is equal to x to the power 6, I would like to tell you one very important thing over here. This graph is called as parabola. Why? Because whenever y equal to some quadratic in x is written, we say that the graph is going to be parabola. These graphs, a lot of guys feel that these are also parabolas, but let me tell you that these are not parabolas. These are not parabolas. We do not call these graphs as parabolas. If you want to draw these graphs on a single graph paper, the graphs will be looking something like this. This is y equal to x square. This is y equal to x square, kids. If you want to draw the graph of y equal to x to the power 4, the graph will be looking something like this. Now why? Let me tell you this one very important thing. If we look at these points, this is 1, 1. And if we look at this point, this is minus 1, 1. Now both the curves y equal to x square and y equal to x to the power 4 satisfies these 2 points. X equal to 1, if you put in any of these, we get y ka value as 1. And if you put x equal to minus 1 in any of these, we do get y ka value as 1. That means these 2 points are definitely common in these 2 graphs. But if we take any number greater than 1, let's say 2, and if we do a square of that number, and if we take a number 2 and make power 4, which number is bigger? The number having bigger power. Yes or no? The number having bigger power is going to be big. So now you guys can feel it. For any value of x greater than 1, y equal to x to the power 4 is going to give bigger value as compared to y is equal to x to the power 2. Yes or no? If you look at x equal to 3, let's say. So this graph is going to give you y ka value 9 only. And this graph is going to give you the value of y as 3 to the power 4, that is equal to what? 81. So obviously this graph is going to give you the greater value of y. That's why in this portion, y equal to x to the power 4 will come higher as compared to y equal to x square. Not only this, but if we take a number between 0 to 1, let's say a number 1 by 3, if we square it and if we make power 4, which one is bigger? Whichever is having lesser power. Yes or no? This happens for each and every number which is between 0 to 1. Yes or no? This is going to be 1 by 9. This is going to be 1 by 81. So obviously this one is bigger. So if we look in the portion between 0 to 1, we guys can see one thing, that y equal to x to the power 4, this green graph will be coming below, because these values are going to be lesser as compared to these values. So this value, this graph is going to come above for those values between 0 to 1, for x belonging to, for the values of x between 0 to 1. Yes or no, kids? Yes. And the similar thing happens on the left hand side as well. I hope you guys can visualize it clearly. Also, if you have studied even function and odd functions, these things will be easier for you guys. We're going to talk about that later in this session. Okay, if you would like to draw the graph of y equal to x to the power 6, what will happen? Can you guys feel it? How the graphs will be looking like, everyone? How the graphs will be looking like? Can you guys feel it? Try to feel it. That if you want to draw these 3 graphs in a single graph paper, what is going to happen? Yes, this blue graph is of y equal to x to the power 6. Yes or no? Feel it? Try to feel it. Because now I am assuming that you have successfully passed class 11th. You must know that these kind of graphs will be forming, right? In a single graph paper. It's very important to feel all these things. Alright, moving ahead. Talking about y equal to x cube, as I told you, the graph will be forming like this. It's quite easy to understand this, because if you put x equal to 1, we're gonna get y as 1 only. If you put x equal to 2, we're gonna get y as 8. if we gonna put x equal to -1, we gonna get -1 comma -1. If we put x equal to -2, we're gonna get -2 comma -8, and so on. So if we put a positive x, we get a positive y. If we put a negative x, we get a negative y. Means the graph will be forming in the first and third quadrants only. Yes or no? And if we put x equal to 0, we get 0 value of y only, that is 0 comma 0. Okay. Now if you would like to plot, same things will happen with any odd power of x. Same things will happen for any odd power of x. Yes, the graph will be formed in the first and third quadrants only. But you have to feel that in a single graph paper, how these three graphs will be looking like. So if this is y equal to x cube, you have to find out which one is of y equal to x cube, which one is of y equal to x to the power 5, and which one is of y equal to x to the power 7. Try to feel it, guys. This yellow graph is going to be of y equal to x to the power 7. This blue graph is going to be of y equal to x to the power 5. And this green graph is going to be of what? Of y equal to x cube. Why? Because for any value of x greater than 1, let's say you have taken any one value, let's say 2. And you are doing cube of that, you are doing power 5 of that, you are doing power 7 of that. Which one is going to be greater? This one, then this one, then this one. Yes or no? If you see the highest one, this value is going to be the highest one, then this value, then this value. So over here we can see that at x equal to 2, if we see, let's say this is x equal to 2. So which value should be greater? X to the power 7 ka value should be greater at x equal to 2. So obviously whichever graph is coming above should be y equal to x to the power 7 in these values. So I hope you guys are clear. Yes, a very important observation that you have to make, kids. Moving ahead, y equal to root x, as we have already seen, the graph looks like this. Y equal to 1 by x, I hope you might have learnt it's a rectangular parabola. It's a rectangular parabola. You must remember these kind of basic graph. The rectangular hyperbola, sorry. If you put positive x, we get positive y. If you put negative x, we get negative y, right? And if you have learnt limits, so I will tell you one thing, that limit extending to 0, 1 by x does not exist. So over here also you guys can see that the limit does not exist. In class 11th you might have studied this. If you talk about y equal to 1 by x square, it does not matter whether x is positive or negative. Ultimately the value of y is always going to be positive. Yes. So the graph will be forming in the first and second quadrants only. I hope you guys can visualize it easily. Moving ahead, talking about exponential functions. So there are two kind of exponential things which can happen. Exponential functions are the functions in which base is constant and power is variable, right? So number one graph is like this. This happens whenever the base is greater than 1. Let's say we would like to draw the graph of y equal to 2 to the power x, y equal to 10 to the power x, y equal to 3 to the power x. That is, we want to draw the graphs of exponential functions having base greater than 1. So the shape will be forming like this. Shah Rukh Khan's, gesture of that wala thing, right? I hope you guys are clear with this graph, right? So any value greater than 1 is there at the base and the power is variable x, then the graph will be drawn like this shape only. For exponential functions in which base is between 0 to 1, the shape forms like this. Now this hence moves up. Okay, this is how the graph forms. Okay, if you want to draw the graph of y equal to, let's say, 1 by 2 to the power x, the graph will be drawn like this, because the base is, whenever the base is lesser than 1 and greater than 0, the shape looks like this. Let's say we want to draw the graph of y equal to 1 by this. If we want to draw the graph of y equal to 1 by 10 to the power x, if you want to draw the graph of y equal to 1 by e to the power x, or we can also say it as e to the power minus x, the graph will be drawn like this. I hope you guys are already aware of this. Okay, so if you want to draw the graph of y equal to e to the power x, now e to the power x, e ka rough value is 2.71, so the base is greater than 1, so the graph will be of this yellow one. Yes or no, kids? So this is y equal to e to the power x, and e to the power minus x can be rewritten as 1 by e to the power x. That means the base is 1 by e, which is 1 by 2.71 roughly. So the base is lesser than 1 and greater than 0. That's why the graph will be forming like this. So this is nothing but the graph of y equal to e to the power minus x. Both of these graphs do meet whenever x is equal to 0 and y is equal to 1. Because if you put x equal to 0 in this and x equal to 0 in this, ultimately you get the value of y as nothing but equal to 1 only. So this common point between these two graphs is nothing but 0, 1. Yep. Okay, moving ahead, logarithm functions. Now the graph of logarithmic function depends upon this base a. If this base is greater than 1, then this kind of a graph is formed. Let's say your mother told you to clean, refrigerator or TV. What do? You do like this, or you can say bye-bye, bye-bye graph. It's a kind of a bye-bye graph, isn't it? So whenever base is greater than 1, the graph forms like this. Let's say I want to draw the graph of y equal to log x base 2. The graph will be drawn like this. If I say draw the graph of y is equal to log x base e, the graph will be drawn like this, or I can also say it like this, ln x. If I say draw the graph of y is equal to log x base 10, the graph will be drawn like this, because in each of these expressions the base is greater than 1. I hope you guys are aware of all this. Okay, moving ahead, kids. Talking about this, whenever base is between 0 to 1, the graph is formed like this. Whenever base is between 0 to 1, the graph is drawn like this. Let's say I want to draw the graph of this thing. Let's say I want to draw the graph of y is equal to log x base 1 by 3. Let's say I want to draw the graph of y is equal to log x base 1 by 10. So whenever the base is between 0 to 1, the graph ka shape forms like this. So I hope you guys are aware of this graph as well. Okay. Yeah, if you want to draw the graph of y equal to ln x, then we know that ln x can also be written as log of x to the base e. Yes or no? If the base is greater than 1, then we have to draw what? Bye-bye shaped graph. Yes? Okay, talking about the greatest integer functions graph, I hope you people are aware that it's a stairs-like graph, or we can also say step function. We also call it as step function, means stairs are there. If you put any value of x belonging between 0 to 1, the value of greatest integer of x is going to be nothing but equal to 0 only. Yes or no? If you put any value between 1 to 2, including 1 and not including 2, the greatest integer ka value is going to be nothing but equal to 1 only. If you put any value of x between 2 to 3, including 2 and not 3, the value of greatest integer of x is going to be 2 only. If you put any value of x between minus 1 to 0, then the value of greatest integer of x is going to be what? The value of greatest integer of x is going to be this only. So here we need to plot these particular things, and I hope now you can visualize it, that the graph will be forming like this. So you must remember this shape. If you have studied a bit of continuity, then you can say that this graph is not continuous at x equal to all integers, right? If you haven't studied about continuity, that's fine, but I hope you remember this graph. Okay, moving ahead, kids. Y equal to fractional part of x. All such kind of things are formed because I hope you are aware the greatest integer of x always goes from 0 to 1 only. It can never take any other value apart from this. All of these lines are having slope 1 only. So if you look at this graph, this will be y equal to x minus 1. If you look at this graph, it will be of y equal to x minus 2. If you look at this graph, it will be of y equal to x plus 1. If you look at this graph, it will be y equal to x plus 2, and so on. I hope you are aware that this kind of graph forms for y equal to fractional part of x. Signum function, it's a very easy function. Whenever this thing is positive, the value comes out to be 1. Whenever this thing is equal to 0, the value is 0 of this entire thing. And whenever this thing is negative, we get the value of y as minus 1. Let's say I would like to know the value of signum of minus 3. Now we know that inside signum number, if we are putting a negative number, the value has to be negative, that is minus 1. If we are putting, let's say plus 4, since it is a positive value, the output should be plus 1. If we are putting a 0 inside this, we get the value 0 only. If you put a positive number inside signum, we get the value as plus 1. If you put a negative value inside the signum, we get a negative 1 only. So this is how the graph will be forming. Look, at x equal to 0, you get a value equal to 0 only. For values of x greater than 1, the graph is formed like this. And for the values of x lesser than 1, the graph gives you the value y equal to minus 1 only. Yes, look. I hope you guys are clear with this thing. Okay, now trigonometric functions. I hope you know that sine ka wave starts from this. This is one interval 0 to 2 pi. Then this same thing gets copy pasted again and again and again. Yes? Okay, so this is how the graph of y equal to sin x looks like. The domain is all real numbers, and if you talk about range, it is minus 1 to 1. Domain means nothing but if you take this particular shape, let's say this one, and if you project it onto the x-axis, this entire portion is covered. Yes or no? If you take this portion and if you project it onto the x-axis, this entire portion is covered. If you take this portion and project it onto the x-axis, this entire portion will be covered. If you take this part and project it onto the x-axis, you get this thing only, right? So that's how we can say that the domain is all real numbers. And if we are looking for range, then you might have studied that range means what? Range means the values on the y. So this portion will be covered if you squeeze the graph like this onto the y-axis. Yes or no? Because this is the highest value and this is the lowest value. So if you do the squeezing like this, then the maximum value is going to be 1 and the minimum value is going to be -1, because below that graph never goes and above this graph never goes. That's why the range is going to be what? The range is going to be -1 to 1. You might have studied this. Similarly, for y equal to cos x, the graph starts from here. This is a very important thing that you have to notice over here, that the graph starts from here. Okay. So here also the domain is all real numbers and the range is -1 to 1 only. Okay. Domain means the values on the x-axis. Range means the values on the y-coordinate. Okay. Okay. Let's talk about y equal to tan x. Yep. Y equal to tan x. This is how the graphs looks like. The domain is all real numbers excluding odd multiples of pi by 2, because at odd multiples of pi by 2 tan x gets undefined, and the range is all real numbers, or you can say -infinity to infinity. Okay. The period, if you talk about the period is nothing but equal to pi, because period is what? From here to here. If you see, same thing happens again and again and again, and this is of the interval length pi. That's why we say that the period is pi, because if you take this portion, copy paste, you get the another one, copy paste, you get the ahead one, and so on. Here the period was 2 pi. Here the period is 2 pi, because if you take from here to here, then one wave gets completed. So here the period was 2 pi. Right? Here also the period was 2 pi. Let me tell you this as well. Yeah. Here also the period was 2 pi. This 2 pi length is copy pasted again and again and again, right? Yep. Moving ahead, kids. Y equal to cos x we have seen, y equal to tan x we have seen. Now talking about y equal to cos x, cosec x. A lot of guys feel difficulty in this, so let me tell you a very simple rule. Let's draw the graph of y equal to sin x first. So this is how the graph of y equal to sin x will look like, yes or no? Now what am I telling you is, this is the graph of y equal to sec x, sorry. Let me draw the graph of y equal to cosec x first. Okay, yes. So let's draw the graph of y equal to sin x first. So this is how the graph of y equal to sin x will be looking like, yes or no, kids? Yep. Okay. Okay, now if you want to draw the graph of y equal to cosec x, what do we do is, we cut the graph wherever the graph of y equal to sin x cuts the x-axis, we basically cut the graphs from there. Now, this portion has been cut, now we simply invert it. If you simply invert it, don't you think that it has to go like this? We simply invert it, it goes like this. We simply invert the portion below the x-axis like this, we get this graph. We simply invert the portion coming above the x-axis like this, we get the graph of y equal to cosec x only. Here the domain is what? Here the domain is all real numbers excluding n pi, where n is an integer, and the range, if you talk about, it is -infinity to -1 union 1 to infinity. As you guys can feel, because if you invert this portion, it will start from 1 and goes till infinity. If you invert this portion, it will start from -1 and then go till -infinity. So the range is going to be this. Over here also the period is 2 pi only. This white graph is of y equal to cosec x. I hope now you are comfortable with this graph. If we talk about y equal to sec x, what do we do is, we take the graph of y equal to cos x, let's say. This is how the graph of y equal to cos x forms. Okay, simply cutting the graph wherever the graph cuts x-axis and then inverting it. Whatever the portion coming below the x-axis, if you invert it, you will invert it like this, and whatever the portion is coming above x-axis, you will invert it like this. So what you get is nothing but the graph of y equal to sec x only, kids. So here if you talk about domain, then you can say that domain is all real numbers excluding odd multiples of pi by 2. And if you talk about range, it is minus infinity to minus 1 union 1 to infinity only. Here if you talk about the period is nothing but 2 pi only. Okay. Yep. Moving ahead, talking about y equal to cot x. I hope you are aware that tan x is drawn like this, so cot x is drawn like this. You must remember this. And we can also simply get it quite comfortably. It's not a big issue. The domain here is all real numbers excluding n pi. And the range is all real numbers, or we can say minus infinity to infinity. Just like tan, here also the period is pi only, not 2 pi. So that's how the graph of y equal to cot x looks like. Okay. You can also remember these graphs by dancing waves as I have represented for you people. Now our agenda for today's session is to learn these graphical transformations. Now what is these graphical transformations? Let's say you are aware of drawing the graph y equal to sine x and y equal to x square. Yes, you are already aware how to draw these graphs. Now with the help of this, if I tell you to draw the graph of y equal to sine of x plus pi by 4, you will be able to do that. If I tell you to draw the graph of y equal to x plus 2 ka whole square, you will be able to do that. That's what graphical transformations is all about. Are you getting my point, kids? Graphical transformation helps us to draw the graphs of complex looking expressions. Let's say I want to draw the graph of sine of x plus pi by 4. Or I want to draw the graph of, let's say, y equal to x plus 2 ka whole square. Or let's say I want to draw the graph of y equal to x minus 2 ka whole square. We can definitely do that by using graphical transformations. Not only this, but if you want to draw the graph of y equal to 2 sine x, that also we can do. If you want to draw the graph of y equal to 2x square, that also we can do. If you want to draw the graph of y equal to minus 2x square, that also we can do. If you want to draw the graph of y equal to sine 2x, that also we can do. If you want to draw the graph of y equal to 2x ka whole square, that also we can do. If you want to draw the graph of y equal to sine x plus pi, okay, we can definitely do. Let's say we want to draw the graph of y equal to x square plus 3, that also we can do. If you want to draw the graph of y equal to minus x square plus 3, that also we can do. Right? If you want to draw the graph of y equal to cos of minus x, that also we can do. If you want to draw the graph of any other expressions, we can do with the help of what? With the help of graphical transformations. So we're going to have a look at these graphical transformations. Let's say I want to draw the graph of this. That also you guys can do with graphical transformations. So our agenda is to learn how to draw the complex looking graphs if we know some basic graphs that we have studied so far. So talking about the first graphical transformation, I would like to ask you one thing over here, kids. If I say that, let's say you are standing at 0, 2. So 0, 2 will be somewhere over here. Yes or no? 0, 2 will be somewhere over here on the positive x-axis. If I tell you that you have to move horizontally from here, you have to move horizontally from here 2 units towards right, 2 units towards right, will you reach to 2, 2 or not? Yes. If I tell you to move 3 units left onto horizontally, on horizontal, parallel to horizontal line only. So will you be reaching over here, that is minus 3, 2 or not? All of you guys. Yes. So what am I trying to tell you is, if I am moving horizontally in the Cartesian plane, the value of x coordinate changes, but the value of y coordinate remains same. Yes or no? If I am moving horizontally anywhere, let's say I am moving horizontally on this line, so the value of x coordinate is going to change, the value of y will remain same. Obviously the equation of this line will be called as y equal to constant only, because any line parallel to x-axis is nothing but y equal to constant. Yes or no? Because over here also, if you see, this line is going to be of y equal to 2 only, that is y equal to some constant 2. So if we are moving horizontally only x coordinate changes, the value of y remains same. Yes, x only changes whereas y remains constant whenever we are changing in x. Yes or no? Or we are moving in horizontal direction. Now let's try to understand this. Let's say I'm saying ki this is the graph of y equal to x square. And I want to draw the graph of y equal to x plus 2 ka whole square. So ultimately, if I go from here to here, what am I doing? I'm replacing x with x plus 2. Hai? Yes or no, kids? I'm replacing x with x plus 2. If I put in place of x, x plus 2, I get nothing but this particular expression. So what am I doing is I am making a change in x. The y is keeping constant only. Yes, changing only x. Changing only x. Y is constant. So if I'm changing x or my x is changing and y is constant, don't you think that I'll be moving horizontally only? Because whenever I move horizontally, y always remains constant. Yes or no? Yes, sir. Okay. Now, there can be two kinds of movement horizontally. One is towards right, like this, and one is towards left, like this. Now, why this has moved? Why, if I wanted to draw the graph of this graph has been moved by 2 units onto the left. Why? That's a question which pops up in your mind. So look, if I'm having this kind of a graph, and I wanted to draw the graph of y equal to x plus 2 ka whole square with the help of this, I understood a rule, and that's what x needed to be replaced by x plus 2. That means x has been changed, so the vertical movement will not be there, only horizontal movement will be there. But there are two kinds of horizontal movement, one is towards right and one is towards left. Now what kind of movement we should do? So let's do one thing. We take a y, any one value of y, let's take any one value of y. Any one value of y, let's take it. Let's say 0. If you have taken any one value of y, 0, so accordingly, if you see, what is the value of x over here? X has to be 0 only, so that y becomes 0. And here also, if you are taking the same value of y, why you are taking the same value of y? Because you are aware that y will always remain constant. So I am taking y same in both the cases because I know that only horizontal movement is going to take place. In order to bring y equal to 0 over here, don't you think that we need to have x equal to minus 2? So earlier this point 0, 0 was there, now it has become minus 2, 0. So this point needed to be shifted towards left or right so that we get to this particular thing. We need to shift this particular thing 2 units towards left so that we reach from here to here. Yes or no? Left movement. Just simply take this graph, push it 2 units towards the left. What you get is nothing but the graph of y equal to x plus 2 ka whole square only. This is the graph of y equal to x plus 2 ka whole square. Look, easy. Sir, why we have taken only y as 0? You can take any other value of y as also, y also, no issues. Let's say you have taken y ka value as 1. If you take y ka value as 1, then x will be equal to 1 or plus minus 1. Let's say you are taking positive values only. Here also, if you take the value of y, what will be the value of x, kids? The value of x is going to be minus 1 or not? Yes or no? So earlier at this point 1, 1 was there. Now this same point when shifted will become what, kids? In order to get y, we need to shift this point by 2 units onto the left. 2 units onto the left means not this one. Let me tell you that this point will be 1, 1. This point is 1, 1. If we shift this point towards left, then on this white graph I am going to get this point minus 1, minus 1. Or you can also see it like this, that let's say I put x equal to 2. If you put x, okay, let's say y equal to 4 you are getting, so you will be getting at x equal to 2. Here you will be getting that value at x equal to 0 only, that particular value. So let's say you are having this point 2, 4. If you shift it 2 units towards the left, don't you think that it is going to reach here now? towards left. This point if you push. So each and every point on this yellow graph, if pushed leftwards by 2 units, we get the graph of this. Talking about the next thing, let's say we are aware that this is how the graph of y equal to mod x looks like. And if you want to draw the graph of y equal to mod of x minus 2, don't you think that the graph has to make horizontal movement only? Why? Because x has been replaced by x minus 2. So only x has been changed, y is still same only. So horizontal movement will take place. Earlier, only horizontal movement will take place means y will remain constant. Let's say I've taken a value y equal to 0. So here I was getting this value at 0, 0. At x equal to 0 only you will get y equal to 0. And if here you want to get the same value of y, that is 0, you need to put x equal to 2. So earlier the point which was 0, 0, if we push it towards right, then only it will become 2, 0. Otherwise, it is not going to happen. So here you can say that right movement will take place. If I say it in simple words, if I know the graph of y equal to f of x, and I want to draw the graph of y equal to x plus some positive number, then I have to move right by that many positive number units. And if I have the graph of y equal to f of x, and I want to draw the graph of y equal to f of x minus that negative number, what do I do is nothing but I move leftwards by that many units. Ultimately, what is happening over here? Ultimately, the thing which is happening over here is x has been replaced by x minus that number. Yes, x minus positive. Over here also it should be positive. But it is x minus positive, okay? Understanding the point? Yep. Okay. These two simple rules. So left movement will take place when x plus positive number has been replaced, and right movement will take place whenever x ke jagah par x minus negative number has been replaced. Yes, everyone? Okay. Moving ahead. Combining these two things together. Let's say I want to draw the graph of y equal to sine of x plus pi by 2 and y equal to sine of x minus pi by 2. Now with the help of this graph we can draw these complex looking graphs, because if x has been replaced by x plus pi by 2, this expression will become this. So only x has been changed, y will remain constant. So x plus positive has been done. So we have to shift this graph left or right so that we get this particular graph. I think left shift is required. And here, if x is replaced by x minus pi by 2, then this particular expression will be formed. So here you need to do a right shift. So if this is the graph of y equal to sine x, if we push it, if we push this point by pi by 2 units, it will come over here. If you push this point by pi by 2 units, it will come over here. So the graph will be forming something like this. And that graph will be of y equal to x minus pi by 2. Yes or no, kids? So let me show you. This is nothing but the graph of y equal to x plus pi by 2, this green one. X plus pi by 2. Because if you push this blue graph towards left by pi by 2 units, then only this green graph will be formed. And if you want to draw the graph of y equal to x minus pi by 2, this yellow one is going to be of y equal to x minus pi by 2, because if you shift this blue graph by pi by 2 units towards right, look, this point has now come over here. So this point has been shifted by pi by 2 units. This point earlier was here, now this has come over here. So that's why pi by 2 shift has taken place. So now you can visualize how the graphs will be looking like quite comfortably. Yes, everyone? Let's say I have been given y equal to x square graph and I want to draw these two graphs. So here you guys can visualize that if x is replaced by x plus 2, the expression will come. That means change in x has happened, not y. If you are replacing x with x plus 2, that means you have to move right. Sorry, left. Why left? Because I think you guys can feel it quite comfortably. And here if you see, the right shift will take place. Yes or no? Feel it. So the graph of y equal to x plus 2 ka whole square and x minus 2 ka whole square will be looking something like this. This graph is going to be of y equal to x minus 2 ka whole square, and this graph will be of y equal to x plus 2 ka whole square. Yes or no, kids? Feel it, try to feel it. You simply have to take this graph and you have to shift it by 2 units to get the graph of y equal to x minus 2 ka whole square towards right, and if you shift this graph 2 units towards left, you get the green graph of y equal to x plus 2 ka whole square. I hope you guys are clear with this. Talking about graphical transformation 2, now talking about whenever y has been replaced with y plus minus a, that means this time y coordinate has been changed. If y coordinate has been changed, the movement will be along the vertical direction, not horizontal. So accordingly, you guys can feel that if y equal to x square looks like this, if you replace y with y minus 2, don't you think that if x will remain same, that means these two things are same, then obviously here y has to be greater, then only these two things will also be equal. Now if let's say y equal to 4 was there, so here if you want to make a 4, you have to take y as 6, that means you have to take y ka value as greater. So whenever y has been replaced by y minus some positive number, the graph goes upwards. This is what I am saying you. Let me write it over here for you people, that whenever y is replaced by y minus some positive number, graph shifts upward. Graph shifts upward. And whenever y has been replaced by y plus positive number, the graph shifts downward. Vertical movement only will take place because I'm changing only y. Yes? So if we know the graph of y equal to x square, and we want to draw the graph of y minus 2 equal to x square, or we can also say it y equal to x square plus 2. Yes or no, kids? If we take this minus 2 onto the right hand side, the graph will be taken up, right? Okay. And if you want to draw the graph of, let's say, y equal to mod x is given to us, and if you want to replace y with y plus some positive number, don't you think that the graph has to go down? Like this, graph shifts down as told you. Okay, so what is the minimum value of this particular expression? Now we are aware that y equal to sine x looks something like this. How? If you want to draw the graph of y plus 5 equal to sine x, now we can see over here that y has been replaced by y plus 5. X is constant only, so we can say that movement will take place vertically only, and also y has been replaced by y plus 5, so the graph has to shift downward. So what if you want to draw the graph of this expression, then you simply need to take this graph 5 units down. So earlier this was highest value 1, so once you take this value 1 5 units down, it will become minus 4, and this was the lowest value of this y equal to sine x ka graph, and this was minus 1. If you take this value also 5 units down, it will go till minus 6. Yes or no? So what will be the minimum value of this new graph y plus 5 equal to sine x? The minimum value is going to be minus 6. Yes or no? Can you guys feel it? Have a look at this, kids. I hope you guys are clear with this particular thing. Yep. And this is how the graph of y equal to sine x will be looking like. You simply need to take this graph 5 units down. Yes or no? To get the graph of y plus 5 equal to sine x. And this is what graph? This is y equal to sine x wala graph. Yes, kids? Okay. Draw the graph of this particular expression. Now, I told you that how the graph of y equal to 1 by x looks like. The graph of y equal to 1 by x looks like this. Basic graphs I told you today. Now, if you replace x with x plus 4, what you get is nothing but this expression y equal to 1 upon x plus 4. Now, change has happened in the horizontal direction only. X has been changed, so change will happen in the horizontal direction only, and that too plus has taken place. So whenever you do x replaced by x plus 4, right shift or left shift will take place? Left shift will take place. And by how many units? 4 units. So earlier this was x equal to 0 line. Now this will be x equal to minus 4 line, about which the graph will be drawn like this. So that's how the graph of y equal to 1 over x plus 4 will be looking like. Simply, you have to take this graph and shift it by 4 units towards left. Yes or no, kids? So let me show you. This is how the graph will be looking like. Are we guys clear? All of you people? Yep, moving ahead. Let's say we want to draw the graph of this. Now, we have just seen that the graph of y equal to 1 over x plus 4 will be looking something like this. This is the graph of y equal to 1 upon x plus 4. Now, if you want to draw the graph of y equal to, if you replace y with y minus 1, this expression will become y minus 1 is equal to 1 upon x plus 4. That is, this expression will be equal to y equal to 1 plus 1 by x plus 4. Yes or no? So y has been replaced by y minus 1. So in this graph, we have to do what? Vertical shifting only, up or down. But what we have to do is up shift. Yes or no? Up shift we have to do. Why up shift? Let's take each and every value above. If you take each and every value above, the graph will be looking something like this. Let me show you. The graph will be formed something like this. Try to visualize it. Try to visualize it, kids. Yes or no? So if I show you the graph will be looking like this ultimately. Yes or no? Feel it. Try to feel this, everyone. We have to take every portion of the graph up by 1 unit. That's what we have done. Okay, talking about the graphical transformation 3. If we are given y equal to f of x ka graph and we are needing the graph of y equal to minus x. That is, whenever x has been replaced by minus x. Now listen. In the graphical transformation 1, we have seen x has been replaced by x plus constant or x minus constant. In the second graphical transformation, we have seen y has been replaced by y plus constant and y minus constant. Here it is multiplication, and that too of minus 1. Yes or no? Because if x has been replaced by minus x means x has been replaced by minus 1 times of x. That means whenever negative number has been multiplied. So there is a rule. If you want to draw the graph of y equal to f of minus x, we first draw the graph of y equal to f of x and then take the mirror image of this graph along the y-axis. That's it. Take the mirror image along the y-axis. Let me show you this in a better way. Let's say you know this graph y equal to 2 plus x. I hope you can simply draw it. Putting x equal to 0, you get y equal to 2. Putting y equal to 0, you get x equal to minus 2. So these are the 2 points from which the graph will be passing, minus 2, 0 and 0, 2. So definitely you can draw this straight line. Now, if somebody asks me that with the help of this graph, can you draw this graph? So yes. Why? Because here if you see, if x is replaced by minus x, this equation will become something like this. Yes or no? Yes, sir. So what's the rule over here? Whenever x has been replaced by minus x, we have to first draw the graph of y equal to f of x, that is whatever was given to us. Then we have to take the mirror image about this. That means the mirror image of this portion will become now like this, and the mirror image of this portion will become like this. So that's how the graph of y equal to 2 minus x will be looking like. Have a look at this. This point will be 0, 2. If you look at the mirror image of this particular point, it will come over here 2, 0. Yes or no? If you say that over here is a mirror, then the mirror image of this point will be what? 2, 0 or not? Yes, feel it? Exactly. So that's how the graph will be drawn. I hope you guys are comfortable with this. Okay, let's take a few more examples based on this. Let's say I was given this graph. Now this is quite easy because you guys can see it's a quadratic expression whose roots are x equal to 1 and x equal to 0. Also, you guys can feel that coefficient of x square is positive, so the graph has to open upward. So let's say you knew how to draw this graph, and the examiner told you to replace x with minus x. The moment you replace x with minus x, the equation becomes something like this, and ultimately it looks something like this. Yes or no? So look, whenever such thing is happening and you wanted to draw the graph of this expression, let's say, what do? You take a mirror over here. The mirror image of this portion will be drawn something like this, and the mirror image of this portion will be drawn something like this. So that's how the graph will be forming. Yes or no? Have a look at this, kids. Mirror image about y-axis. So this point ka mirror image about this axis is going to be -1, 0. Look. Easy to understand? Alright, moving ahead, talking about the transformation 4. If y has been replaced by -y, if y has been replaced by -y, we have to do the same thing, but about the x-axis, we need to take the mirror image. Let's try to take an example. Let's say I have been given this graph. I know that this graph looks something like this. And if I replace y with -y, don't you think that this particular expression will become like this? Now, how do we draw the graph of this is we just take the mirror image of whatever the graph we are having over here about the x-axis. Let's say some mirror is placed over here. And if you are taking the image of this portion, so it will obviously go down like this. So that's how the graph of y equal to minus mod x will look like. Understood? So whenever x has been replaced by -x, mirror image is taken about y-axis, and whenever y has been replaced by -y, mirror image is taken about the x-axis. Right? Okay, let's say we want to draw the graph of this particular expression. Now I hope that you are aware that y equal to x square can be drawn how? With the help of this, you guys can draw this graph, and with the help of this, I think you can definitely draw this graph now. Yes or no, kids? Look, this graph opens up like this. Now, in order to reach from here to here, ultimately y needs to be replaced by y minus 1. Yes or no? Feel it? If you replace y over here by y minus 1, then that -1 will go onto the right hand side and it will become like this. And here, if you replace y by -1 minus y, don't you think that this graph will be formed? Yes, sir. Okay. Now, let's learn a few more rules. If we want to reach from this graph to this graph, we have to do upshifting. Remember, y को y minus constant से करेंगे, तो we need to shift up. And whenever y is replaced by -y, we take mirror image about x-axis. Yes or no? About x-axis. Yep. So earlier, if you look at this graph, this is how the graph will be forming. If you take 1 unit up, the graph will form something like this. This point will become 0, 1. And if you take this graph and form its mirror image about the x-axis, then only we get the graph of this. The graph we will be getting will be looking like this. The mirror image of this expression 0, -1. 0, 1's mirror image about x-axis is going to be 0, -1. Yes or no? Are you clear with the pattern that is there? There can be multiple ways as well, okay? Yeah, to draw this graph. But you can feel that the graph will be looking like this. Y equal to x square. With the help of that, we have drawn the graph of y equal to x square plus 1. If you wanted to go from here to here, we have replaced y with y minus 1. So upshift we will do. And if from here to here we want to reach, so y needed to be replaced by -y means mirror image about x-axis has to take place. Yes or no, kids? Moving ahead, talking about few more graphical transformations. If x has been replaced by k times x. Now remember, graphical transformation first, x was replaced by x plus positive or x minus positive. So summation and subtraction was there. In the second graphical transformation, we did y replaced by y plus constant or y minus constant. Third wala, x has been replaced by -1 times x, -1 times x. Then fourth one, we did y has been replaced by -1 times y. Now we are learning fourth one, that is if x has been replaced by kx, what do we do? Whenever k is between 0 to 1, horizontal stretching will take place because we are changing in x only, so horizontal change will happen. Now here are two things, stretching and shrinking. If k is greater than 1, then shrinking means compression will take place. I'll tell you how this compression will take place. And if k is between 0 to 1, then horizontal stretching will take place. Let's talk about this. Let's say I have been given this y equal to sin x ka graph. Obviously this green one is the graph of y equal to sin x. If we want to draw the graph of y equal to, okay, no. Obviously we can see that this yellow one is the graph of y equal to sin x. Yes or no? I hope you might have studied about periods. So if the period of this expression is pi, the period of this expression is going to be, the period of this is 2 pi. the period of this is going to be pi by 2 only. Oh, sorry, 2 pi by 2. That is the coefficient of x. We divide it. So that's why it comes out to be pi only. So the period has been reduced. Yes or no? And also you can feel one thing, that whenever x is replaced by some constant into x, and if this constant is greater than 1, compression will take place. Whenever this constant is greater than 1, compression will take place. Means what? You have taken this y equal to sin x and compressed it. Why you have made it half is because you have multiplied it by 2 over here. Look, it was 0 to 2 pi over here, and you have made it to half. Why half? Look, one cycle has been completed. This is the graph of y equal to sin 2x. Why it has been made half? Why it has been made half is because over here 2 is written. If I do sin 3x, then I have to make 1 by 3 of that. So I have to close it at 2 pi by 3 only in that case. If I wanted to draw the graph of y equal to sin 3x, then I have to complete one wave. I have to complete one wave till 2 pi by 3 only. Here I have completed the one wave at 2 pi by 2, that is equal to pi. Here I'll complete the wave at 2 pi by 3 only. If I wanted to draw the graph of sin 4x, I have to complete the wave at 2 pi by 4 only. So that's how I get the period also. I hope you guys are clear. Okay, while doing this compression, you need to remember one point, and that's what, whatever the, because look, the graph of y equal to sin x will go here also, like this. So this also will, compression will take place on both the sides. Okay, compression will take place on both the sides. So you have to be a bit careful with that. Okay. Yep. So let me show you. Over here one wave has to be completed, and over here another wave has to be completed. So that's how the graph will be looking like. Okay. Remember one thing, whenever x is replaced by kx, the points on the y-axis remains same for every graph. Points on the y-axis are hinged. Points on the y-axis are hinged. What am I trying to tell you? Let me give you an example over here. Let's say I have been given y equal to x square plus 1. So the graph will be looking something like this. I hope you are aware now. This point is 0, 1. And I wanted to draw the graph of y equal to 3x ka whole square plus 1. That means x has been replaced by 3x. So whenever k is greater than 1, compression will take place. But in order to do the compression, what we do, whatever the points are there on the y-axis, we first hinge those points, and now we started compressing it. So if you start compressing it, the graph will be formed like this. Are you getting my point? So that's how the graph of y equal to 3x ka whole square plus 1 will look like. Okay. Yeah, let's talk about these few graphs like this. Okay. So I hope you are aware that y equal to sin x looks something like this. So this is 2 pi. Okay. And if you draw it further, it will look something like this. Right? Okay. On the back side also, the graph will be drawn like this. So if you want to draw the graph of this, you need to replace x with 2x. So first you will do what? You will hinge the points onto the y-axis. And here if you do, you need to replace x by 2. So over here compression will take place, compression, and that too 2 pi by 2. So over here only one cycle will be completed. Over here only one cycle will be completed. So it will be drawn like this. So that's how the graph of y equal to sin 2x will come. One cycle has completed at pi itself. Why? 2 pi by 2. That is equal to pi. Yep. If you talk about this, stretching will take place. stretching will take place, and if you write it 2 pi over 1 by 2, it will become 4 pi. So in 4 pi, one cycle will be completed. So if you draw this, the graph will be looking something like this. Okay, I hope you got the point. I hope you understood the agenda. This is the graph of y equal to sine x by 2. This point will be 4 pi. Why? As I have told you over here, 2 pi over 1 by 2 you're gonna do. So that comes out to be 4 pi. I hope you are clear with this. Similarly, you can draw these graphs as well. Talking about the stretching, stretching means first hinging the points on the y-axis and then stretching it like this. This happens whenever a is between 0 to 1, and whenever a is greater than 1, compression takes place. A is greater than 1, compression takes place. Between a is between 0 to 1, stretching takes place. Okay, note that unlike for the y direction, bigger values cause more compression. I think you guys are clear already, है ना? So that's how the graph of y equal to sin x looks like. Now this is this yellow one. No, there is some error in this. This is of y equal to 2x. Okay, no, let me show. So this blue graph is of y equal to sine 2x. This blue graph is of y equal to sine x by 2. This yellow graph is of y equal to sine 2x. And this green graph is of y equal to sine x. I hope you can visualize it quite neatly now. Yes? Okay, if same thing happens in y, that y has been replaced by ky, in that case, if k is greater than 1, shrinking will take place. Between 0 to 1, shrinking will take place, and if k is greater than 1, stretching will take place. Here, points are hinged on the y-axis first. Points on x-axis are hinged first. I'll tell you the meaning. Yeah, let's take a few examples. Okay, let's take a few examples first to understand this. Over here, you guys can see that if I have been given this graph and from here I want to reach here, I need to replace y by y by 2. Yes or no? We need to replace y with y by 2. Yes or no? So over here, the value of k is nothing but 1 by 2. And whenever k is between 0 to 1, what happens? Stretching takes place. Stretching. You have to first hinge the points onto the x-axis. Isko hinge kar diya, and then you have stretched it. So on a single graph, if you see, this is how the graph of y equal to 2 mod x will look like. And if you see that if you want to go from here to here, you need to replace y by 2y. So if you put 2y over here, then it will become 2y equal to mod x. Then you take that 2 in the denominator, you get something like this. So here you do the compression, because k is equal to 2. You do the compression or shrinking. In order to get better feeling, let's take few more examples. Let's say this is the graph of y equal to sine x. And with the help of this, you want to draw the graph of y equal to 2 sine x. So if you want to reach from here to here, you need to replace y by 2. Yes or no? If you replace y by 2, you're going to get this expression only. So over here, you guys can feel that first we have to hinge the points onto the x-axis. First hinge these points onto the x-axis. And now compress it. The part which is above the x-axis, pull it like this, and the part which is below the x-axis, pull it like this. Ultimately, you're going to get the value of 2 sine x, because the k is 1 by 2 and k is equal to 1 by 2, which is lesser than 1. That's why elongation or stretching will take place. If you want to draw the graph of 0.5 sine x, here compression will take place. Why? Because if you want to reach from here to here, you need to replace y by 0.5. That is equal to y by 2y. So k is equal to 2. Whenever k is greater than 1, you do the shrinking. So look, what you have done is, you have first hinged this yellow graph wherever on the x-axis, and then you compress it to get the green graph, which is of y equal to 0.5 sine x. Can you feel it, kids? Yes? Okay, so what is the midline and minimum value of this particular thing? First, you know y equal to sine x ka graph. With the help of that, can you get the graph of y equal to 4 sine x? With the help of that, can you get the graph of y equal to 4 sine x plus 2? I think it is quite easy for you people now. So y equal to sine x looks something like this. 4 times sine x. So we need to hinge over here and then stretching it. So ultimately this was 1 and this was minus 1. So now it will go 4 and minus 4. Yes or no, kids? Okay, then y needed to be replaced by y minus 2, so that we get, if we replace y with y minus 2 over here, then only this will happen. So we need to take this graph up by 2 units. If you take this graph up by 2 units, so over here the minimum value will be found minus 2, and from here 0, 2 the graph will be formed, and the graph will be found like this. Yes or no? I hope you guys are clear. The midline, which was earlier y equal to 0, will now become y equal to 2. Midline means, and this point is 6, because earlier it was maximum value 4, 2 units up if you take, this will be y equal to 6 line. So the maximum value will be 6, and the minimum value will be minus 2, and the midline will be y equal to 2. So midline y equal to 2, minimum value will be minus 2. So this is the answer. I hope you guys are clear with these graphs. Okay, so this is how the graph will be looking like. Moving ahead, transformation 7. If x has been replaced by mod x. If x has been replaced by mod x, you don't need to worry. There is a simple rule. First, draw the graph of this, and in this graph, remove what? Remove the portion of the graph in the left half. Okay, remove the portion in the left half. That is negative x-axis wala portion ka graph you need to remove. Once you are done with that, take the mirror image of portion in the right half, in the positive x-axis side mein jo bhi hai. Also include the right portion of the graph y equal to f of x, and that's it, you get the graph. I'll tell you simple example and it will be easier for you to understand. Let's say we have been given this particular graph, and with the help of this we wanted to draw this. So x has been replaced by mod x. So what's the rule? Whatever the portion coming in the negative x-axis, that means this portion, first remove it. That means the portion which is coming on the left of y-axis, remove it. Okay. Keep the portion on the right of the y-axis as it is, and just take its mirror image about y-axis. If you take the mirror image of this portion about y-axis, the mirror image will be formed like this. Okay, so now this is the entire graph. Remove the portion which is coming on the left of the y-axis. Whatever portion is left, take the mirror image about the y-axis. That's it. So that's how the graph of y equal to 2 plus mod x will be looking like. Let's take few more examples. If we are talking about y equal to mod x, then y equal to minus mod x will take place like this, because y needed to be replaced by minus y, and whenever y is replaced by minus y, we have seen that mirror image about x-axis takes place. Now once we have drawn this, if we replace y by y minus 7, then y minus 7 if you put over here, so it will become y equal to 7 minus mod x. So if you want to draw from this graph to this graph, we need to shift up this graph by up 7 units. Simply do this, you get the graph of y equal to 7 minus mod x. Yes or no, kids? Okay, we have seen this graph as well. Okay, over here something is there. One more transformation, and that's what? No. X has been replaced by x mod x. What do we do in the same rule we have seen? We remove the portion which is coming on the left of the y-axis and just take the remaining portion's mirror image also about the y-axis. So that's how the graph of this particular expression will be looking like. Feel it, everyone? The graph is drawn. Yep. Last transformation, that if f of x has been replaced by mod of f of x. The entire f of x has been replaced by mod of f of x, not just, this is wrongly written over here, not just x has been replaced by mod x, but the entire f of x has been replaced by mod of f of x. Then the rule is quite easy. Let's learn it with an example. Let's say we are given this particular graph and we want to draw this. Look, x square minus 4. That means the entire x wala expression has been replaced by modulus of that expression. So what do? We first remove the portion below the x-axis. Keep the portion above the y-axis, above the x-axis as it is, and just take the removed portion's mirror image about x-axis only. This is the removed portion. We just take its mirror image about x-axis only. This is how the graph is formed. Understood? The portion which has been removed, we take the mirror image of that portion only. So that's how the graph is formed. Clear? Let's say we are given this and we want to draw the graph of this. So what do? We remove the portion which is coming below the x-axis. Then the portion which is removed, we take the mirror image of that only about x-axis. So can you feel it that the graph will be looking something like this? That's it. The graph is drawn. Right? If you want to draw the graph of this expression, you have to do this as part of homework, and you have to see by solving the DPPs that whether you are comfortable to solve the problems of graph now or not. Right? So we're gonna end the session here only. I hope that you're gonna revise all these things again and again and again, because the more you're gonna revise, then only you can retain. So revise again and again, because I hope if you revise again and again, you will definitely master these graphs, because I have covered each and everything that is required in class 11th. Because I'm also assuming that you people have already studied these things. That's why the session has been a bit short, but I hope that this session has helped you. See you in the next session. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this, kids. Thank you so much. Bye bye. Take care. Happy learning.